Okay, this is a system of equations because we have two equations. We need to decide if we're going to use substitution or elimination. Since neither equation says just x equals or y equals, it is not substitution. We do have our x's lined up, our y's lined up, and our numbers lined up, so that means this is an elimination problem. If I look at my x's, I would need to multiply both equations to get them to be 12x. If I look at my y's, I only need to multiply one equation, so that is easier. I'm going to multiply this second equation by 2. My goal here is because I want that to be a 4y, so that it cancels with the negative 4y. Alright, so now that I know what I'm multiplying by, I'm going to rewrite my equations. I get the same exact thing on the top, no changes. But on the second one, I've multiplied now, so I get 8x plus 4y equals negative 16. Alright, now I can go ahead and add them up. 3x and 8x here gives me 5x. Negative 4y and 4y cancel completely. 11 and negative 16 is negative 5. Divide. X equals negative 1. However, a system of equations has a solution as a point, so I really only have my x value now. So I'm going to plug this back into one of the original equations. I'm just going to choose that first one. So I've got negative 3 times x, which I now know is negative 1, minus 4y equals 11. Okay, and I got that right here. This equation is the same as this equation, except I plugged in negative 1 for x. Alright, I get a positive 3 there. Get a minus 3 on both sides. I'm going to continue my work up here. We get negative 4y equals 8. Divide by negative 4. We get negative 2. And there's my answer. Alright, this next one, also a system since it has two equations, so I know my answer is going to be a point. We do have y equals, and so we are going to use substitution on this one. So I'm going to substitute here this in for y. So we get negative 8x minus 2 equals negative 5x minus 5. Okay, substituted in that part there. Okay, now I go about solving. I'm going to add 5x. That leaves me still with negative 3x over here. Now I'm going to add 2, trying to get x alone. Negative 5 and 2 is negative 3. Divide, and we get 1. Okay, that's going to go in our solution there. Then I have to plug that back in. I'll plug it back into that top equation. Y equals negative 8. X is 1 minus 2. That gives us negative 8 minus 2, which is negative 10. Alright, this is a substitution problem. We're going to plug that in for y. So we start by writing this equation here, negative 2x minus, but when I get to y, I'm going to plug in negative 3x minus 4. Negative 2x, that's going to be a negative 1 that I'm distributing, so I get plus 3x plus 4. Combine like terms, negative 2x and 3x is a 1x. Minus 4 on each side. We get 2. But we need our y value, so I'm going to plug y back into the original problem. Negative 3x minus 4. That gives us negative 6 minus 4, which is negative 10 for our y value. Our word problem, I'm skipping straight to the end. What is the price of a senior ticket and a student ticket? So I'm going to let, let's see, senior be S, I'm going to let, oh, we've also got a student ticket. Okay, so in this case, I should have read all of it first. I don't really want to use S because I might get confused senior and student, so I'm going to go ahead and actually use X and Y here. And this is where it's very important to have what X and Y are representing so that later we can figure that part out. All right, going back and reading our problem now. School leases go to selling tickets. On the first day of sales, they sold 4 senior citizen tickets and 5 student tickets for a total of $102. Okay, so 4 senior and is a plus, 5 student equals 102. That gives me one equation. It represents that first day of sales. Okay, continuing. They took in $126 on the second day by selling 7 senior and 5 student. So that's going to be another equation. We want to make sure we're lining things up. So I know it says 126 first, but we want to line that up with what we had already chosen on our other problem. We've got 7 senior, those are the X's, and 5 student. Okay, and we have an elimination problem here because neither of these equations are X equals or Y equals. So I need them to cancel. I do see my Y's are both 5, but I need one of them to be negative. So I'm going to multiply this by -1. That gives me -4X, -5Y, and -102. Okay, so not too bad of an elimination problem here. Now we can go ahead and add them up. So we've got 7x and -4x gives us 3x. Okay, that was here. 5y and -5y is gone. And then over on the other side, we've got 126 minus 102. That gives us 24. Divide by 3. X equals 8. Now what was X? I can look back up here. It was senior tickets. So senior tickets are $8. Okay, now I need to find student tickets. So I've got to plug that 8 back in. I can plug it back into either of my equations. So I am just going to choose the red equation that I have there. So 4x, which I now know is 8, plus 5y equals 102. That gives us 32. And minus 32. 5y equals 70. And then we're going to divide by 5 on both sides. Y equals 14. Y represented student tickets. I ran out of room a little bit here. So senior tickets are $8 and student tickets are $14. So we've got to have our full sentence there that represents our answer. Okay, so what we learned is with triangles, they have 6 parts, 3 angles and 3 sides, but we only need 3 of them to show congruence for any of our congruent statements. So when you first look at the triangles, you're just kind of looking for what they gave you already. They marked these sides as congruent, so knowing those, I've got a side. Okay, and then I look for other things, and we've got these sides. That's another side. Now notice I'm not putting them together because I'm just finding what I have first. That's only 2 pieces. We do have to have 3 for any of our triangle congruence properties. So it's our job now to find more. And we learned that these angles right here, when we have this X that happens, these angles are congruent. Those are called vertical angles. So those are vertical angles, so I also have an angle. So I have a side, I've got another side, and I have an angle. Now I can't just put those together however I want. I have to look at the figure and say, okay, where is the angle in regards to the sides? And I can see that the angle is in between the sides, so that's how I would have to write my answer as well. the angle in between the sides, so this is a side angle side. Okay, now we do have to explain it, so we have to do a little bit more work. We have to say, since HK is congruent to MK, and JK is congruent to LK, and angle HKJ. Now notice we cannot just call that angle K because there are multiple angles at K. So we had to use 3 letters. We learned how to do that. And then HKJ has to match, and the order here matters, so it would have to be MKL. Okay, and so now we've stated the congruence property and we've explained with this information. So that is a complete proof. Okay, for our last one here, we're looking for the pieces we know. We know that DC is congruent to BC. So that's one set. We've got a side. I'll go ahead and start writing my explanation over here. Since DC is congruent to BC, so that's our side. And then we also have these right angles marked. If they're both right angles, that means they are congruent. So I also have an angle here. And we also cannot just call it angle C because there's 2 angles there. So angle DCA, remember C has to be in the middle. And then I have to match on the other side, so since I started with D, that matches with BCA. That's only 2 pieces, we have to have 3, so now we're on our own to find another one. On the last one we had vertical angles because we had that crossing angles situation. We don't have that here. What we have here is that we have 2 triangles that are smushed together. They share this side right here, and that is called a reflexive side. Okay, so we do have that side AC is congruent to AC. And we should say why. Since it wasn't marked, we need to state why we were able to know that. Alright, so we have our 3 pieces, and now we're looking to see which one it's going to be. It's not side, side, side. We don't have 3 sides. It's not angle, side, side. It's not side, side, angle. It is side, angle, side, because the angle is between the 2 sides that we have.